Hello guys, Het Gandhi here. I hope you are doing well. In this video, we are going to talk about minesweeper game and various algorithms to solve it. This is our discrete mathematics project, so let's jump straight into this video. So these are the topics which we are going to discuss. Introduction, history, basic parameters, complexity, algorithm, naive single point, double set single point, performance analysis, CSP method, conclusion. Let's start with the introduction of Minesweeper. Minesweeper is a single-player puzzle game. At start of the game, the player receives an encrosame rectangular grid of covered squares or cells, which are described in this picture. Every square of the grid either contains a number from 0 to 8 or mine under it. When the player props a cell containing the mine, then the game ends. So now we talk about brief history of Minesweeper. The original version of game was developed in 1989 to 1990 by Robert Donner. It was inspired by Ian Andrew called as Mind Out in 1983. This game was inspired by another game published in 1983 called Mind Out, developed by Ian Andrew. Let's see some basic parameters of the game. We start the game by clicking on the random square. If we get a number by clicking on the square, it represents the number of mines around that square. The number varies from 0 to 8 because the maximum neighbors around that square can be 8. And if we get a mine by clicking on the square, then the game ends and you lose. There are basically three types of difficulty level of Minesweeper, which are beginner, intermediate, and expert respectively. Now we will delve into complexities. In 2000, Richard Kay suggested that Minesweeper was computationally difficult and suggested in his paper that Minesweeper is non-deterministic polynomial time complete. The verifier checks that these mines produce the numbers on the board. Performing this verification takes polynomial time with respect to the input size. Therefore, consistency is in non-deterministic polynomial time. Here we see algorithms which are helpful to solve Minesweeper. There are many algorithms like Adamski model as a cellular automaton, a single point algorithm which was given by Casper Pedersen. This approach was already available by the name of PGMS Programmer's Minesweeper, but he gave the more formal definition about that algorithm. There is one more algorithm which is called CSP, Constraint Satisfaction Problem. CSP is the best algorithm for the Minesweeper. There are two more algorithms which are NS naive single and DSSP double set single point. We will talk about it in details. Let's take a closer look at cellular automaton. A cellular automaton defines a set of states Q and the transition function of f which takes a state at time t to the state at time t plus 1. In Andrew Adamski's model, each state is represented as a tuple. More specifically, the set of states is defined to be the following Cartesian product. So these are the transition functions. In cellular automaton, we start with a given state at time t, then we use the transition function to reach out the next state at time t plus 1. When the state at time t plus 1 is equal to the state at time t, then it is called the stationary configuration and the transition function comes to an end. This doesn't imply the game ends. As we explained before, the handling guesses is more crucial. Despite its tendency to become stuck, the CA approach is useful in identifying the strengths and weaknesses of single point model. Now let us continue our discussion with first algorithm, naive single point. In the game of Minesweeper, a naive single point refers to the strategy of clicking on a single unopened cell without considering any surrounding cells or available information. It is not a recommend strategy because it relies solely on luck and doesn't take into account the clues provided by the numbers on the revealed cells. Minesweeper is a puzzle game where the objective is to uncover all the cells on a grid without detonating any hidden mines. Each cell can be in one of three states: unopened, opened, or flagged as a potential mine. The numbers on the open cells indicate how many mines are present in the adjacent cells. The player's task is to deduce the locations of the mines based on these clues. When playing Minesweeper, a more strategic approach is to consider the numbers on the revealed cells and use logical reasoning to deduce the locations of the mines. By analyzing the clues, you can make educated guesses about the mines, placements, and avoid clicking on them. This involves looking at patterns, identifying safe areas, and marking cells that are likely to contain mines. Using the naive single point strategy may result in random clicks, which can sometimes lead to uncovering a mine and losing a game. It is best to take a more thoughtful and systematic approach to increase your chances of successfully clearing the minefield. So now, brief introduction on double set single point, which we include in our topic. The double set single point technique is a strategy used to determine the status of a specific tile on the game board when there is number square surrounded by two sets of mines. It involves considering all possible mine configurations and analyzing their implications. In this method, we have two sets S and Q. S contains all the safe squares. Q contains all the squares which do not fall into AFN, all free neighbors, and AMN, all mine neighbor. Definition of AFN. The cells which have all its neighbor containing only numbers and not any mine is called AFN. Definition of AMN. The cells which have all its neighbor containing only mines is called AMN. Ultimately, we can say that Q contains the squares which are basically boundary cells which separates the covered and uncovered cells which you can see in the adjacent figure. There are various formulas to find probabilities using double set single point method. Now we are going to analyze difference between DSSP and NSP win probabilities. Let's try to an analyze of that two algorithms win probability with respect to mine density with constant 9 cross 9 board size. Here we can clearly see from the graph that the win probability of DSSP algorithm is slightly higher than NSP because NSP contains higher guesses than DSSP. Win probability is directly proportional to board size. This is the graph of win percentage versus board size when mine density is fixed. Here we can see from the graph that the difference between the win probability of both algorithms is directly proportional to the board size. From both the graph, we get the conclusion that win probability is inversely proportional to board size. Here we can see that DSSP is much successful algorithm as it contains less guesses because guesses is inversely proportional to win probability. Now let us continue our discussion with CSP method, constraint satisfaction problem. There are three components to a constraint satisfaction problem: a set of variables, a set of domain for each variable, and a set of constraints. The objective is to find a value assignment for every variable such that none of the constraints are violated. Let's analyze one example. Here from this image we can see that there are three constraints. It gives us three equations. A plus B is equal to 1 and A plus B plus C is equal to 1 and B plus C is equal to 1. By analyzing the above three equations, we can see that A is equal to 0, C is equal to 0 and B is equal to 1 are satisfying all three equations. Thus, we can say that B contains mine and A and C don't. This is the best strategy for solving minesweeper game. Now we look what we have done so far. We have seen the different algorithms to solve the minesweeper game. We have seen only the basic of each method in PPT. For detailed explanation, you can see our PDF or you can visit our website. The link of the website is also given in the description. From looking at all the algorithms, we can conclude that the DSSP method is more efficient and you can also apply that when you play the minesweeper game. Let's play the game and see the practical demo of the game. If you want to play the game, link is mentioned in website and also given in the description. Thank you for taking the time to watch this video.